Today we're going to be talking about adding exponents. The technical way to put that is we're going to be applying the product of powers property. Objectives. By the end of this video, you should be able to multiply two like bases and add their exponents. In order to accomplish this, we're going to need to define a base, exponent, and variable. We're going to need to learn how to multiply like bases, and then we're going to need to learn how to multiply like bases with something called coefficients. Okay, we're on to our first sub-objective, which is to define a base, an exponent, and a variable. What does 3 squared equal? Well, hopefully you'll know that's 9, and the reason that it's 9 is because 3 squared is 3 times 3. Which answers our second question. How else can you write 3 squared? You can write 3 squared as 3 times 3. In this example, 3, the number down below in a slightly larger font is our base. The number above the 3 and to the right, now that's important that it has to be above and to the right, is the exponent. Let's look at an example. How else could you write 5 to the 4th? To do that, you need to identify the base and the exponent. Your base is 5, and your exponent is 4. So, we take our base, notice 3 squared, so you took 3 times 3. We're going to take our base, which is 5, and we're going to multiply it by itself 4 times. 5 times 5 times 5 times 5. So the 4 tells us how many times to multiply the 5 by itself. Our last definition is a variable, and a variable is a letter that represents a number. Any letter in the alphabet. X to the 4th, what does that mean? Well, x is your base, 4 is your exponent, so it means x times x times x times x, 4 times. 1, 2, 3, 4. A good key guiding question for the rest of what we're going to do is what happens when you multiply two things with exponents. The first thing we need to do is look at it is to see if they have the same bases. Well, let's explore this just a little bit more. And hopefully you'll be able to identify the property on your own. Let's expand the following. X to the 3rd times x to the 4th. So notice, we are multiplying two of the same base. The x's are the same, the bases are the same, so let's see what happens. X to the 3rd, x times x times x. I've expanded x to the 3rd by writing it out as multiplication. Now, two parentheses next to each other means that you're multiplying those two parentheses together. So x to the 3rd times x to the 4th. So times x to the 4th. Well, x to the 4th is x times x times x times x. Notice you've got 1, 2, 3, 4, 5, 6, 7. So x to the 3rd times x to the 4th can be rewritten as x to the 7th. What exponent do you think x is raised to when nothing is written? Well, let's look at it. X times x to the 7th. Okay, let's expand x. Alright, it's already expanded. It's just x. X to the 7th. How many total do you have? You've got 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. So x times x to the 7th is x to the 8th. Notice that if x does not have an exponent, it is understood to be 1. A bit of a trick question. What do you think x to the 42nd times x to the 56 equals? Yeah, we're leading up to the property here. Hopefully you see a pattern. 3 plus 4 is 7. 1 plus 7 is 8. Oh, so 42 plus 56 is x to the 98. You just add the exponents when you multiply two of the same bases. Drumroll, please. We are now to the product of powers property. When you multiply like bases, you do something to the exponents. What was that? Oh, yeah, you add them. Alright, let's take a look at some actual problems where we're going to have to do something called simplify. Y'all, simplify in this instance just means that we're going to make it look a little simpler by using our property we just learned. Okay, by the way, these things are called algebraic expressions because they contain letters and numbers. X to the fifth times y to the fourth. What do you suppose that equals? No, not x to the ninth. What's wrong with this? Why can you not multiply x to the fifth times y to the fourth? Because it's x to the fifth times y to the fourth. They're not the same base, so you can't use your rule. By the way, if you have two things in parentheses, x fifth, y fourth, they're being multiplied because the parentheses are together, remember. You can also write that as x to the fifth times y to the fourth with nothing in between them, and that means the same thing. It means they're being multiplied. Let's take a look at the next example. x4, x7, y3, y2. Go ahead and simplify that. You might be having a little bit of difficulty. Let's take a look at it one pair at a time. What would x to the fourth times x to the seventh be? Well, it would be x to the 4 plus 7, or x to the 11. Okay, y third, y squared. What would that be? Oh, what would be y to the fifth? Guess what? You just simplified an algebraic expression that had two different variables, x and y. But you might be saying, well, why can you do that? The answer is because you have bases that are the same and you're multiplying them. So anytime you have two of the same bases, you can add their exponents. Take a look at the next one. X to the ninth times y, x squared times y squared. Y'all, there's a property in multiplication that means if you have a string of things being multiplied, you can just change the order. It's the same thing as x to the ninth times x squared times y times y to the 12th. You might notice there's an exponent missing. Remember, y is the same thing as y to the first. So this gives us x to the 9 plus 2, or x to the 11, y to the 1 plus 12, or y to the 13. You try the next two on your own. Go ahead and pause the video. When you're ready to see the answer, go ahead and press play. Okay, the next one is x to the 7th, because 1 plus 6 is 7. Y to the 3rd, it didn't have any like bases, so we couldn't add any exponents. And z, I'm going to put a little line through my z so you know it's not a 2. Z to the 2 plus 3, which is z to the 5th. Alright, last one. The only two like bases you have being multiplied are x to the 5th and x squared. So it gives me x to the 7th, y to the 3rd, z to the 8th. Alright, that gets us through the second objective. We got one more objective to go. Okay, now we're going to learn how to multiply bases with coefficients. Ooh, that's a different word. Coefficient. There's something that's called a coefficient that makes this property look a little different. Let's define coefficient, and I'm going to do that through an example. Y'all, we have a 5, we have a y, and we have a squared. The 5 is that number in front of the y. Notice the 5 is the same font size, it's the same size as the y, and it's right next to it, meaning 5 is being multiplied by the y. The 5 is called our coefficient. The y still is our base, and the squared is still our exponent. Looking at our first example, what's 2 times 3? Okay, yeah, it's 6. And x squared times x to the third. Well, 2 plus 3 is 5, so it's x to the 5th. Now comes the weird part. What about 2x squared times 3x to the third? First thing I'd encourage you to do is to think about your like bases. X squared and x to the third. So x's are the same. And remember what we did earlier. Remember, if you have a string of things being multiplied, you can change their order. I can rewrite this as 2 times 3 times x squared times x to the third. Well, that's just the same thing as 6x to the 5th. So notice, when there's numbers in front of the x's, you multiply those numbers that are out front first. Then you multiply your like bases by adding their exponents. Alright, I got a few examples for you to try. Go ahead and pause the video. Try to work out those examples on your own and press play when you're ready to see them worked out. Okay, let's look at that first example. Remember, we can rewrite that as 4 times 5 times x to the third times x to the 4th, which is the same thing as 20x to the 7th. Okay, second example, 3x squared times 5y to the third. We can rewrite that as 3 times 5 times x squared times y to the third. That gives us 3 times 5 is 15, and yeah, different bases, so it's just x squared y to the third. Can't add the exponents because the bases are different. Next one, I'm going to stop rewriting it out all the way because it's going to save me a lot of time. So let's take a look at this. 4 can be multiplied by the 7 because 4 and 7 are coefficients, giving me 28. X squared times x to the third. Y squared y gives me 28. X to the 5th, y3, y1, y to the third. Next one, 8 times 7, 56. X squared, x to the 6th gives me x to the 8th. Y times y to the 4th gives me y to the 5th. Z to the third times, oops, no more z's, gives me just z to the third. Notice again I put the dash to the z so it doesn't look like a 2. And that leaves us with the last one. 4 times 3 times 8. I'm actually going to write that one out. 4 times 3 times 8. X fourth, see if I've got any other x's. I do, x to the 5th. So it's x4, x5. Y squared, y4. Z fifth, z third. So that leaves us 4 times 3 is 12, times 8 is 96. X fourth, x fifth gives me x to the 9th. Y squared, y to the 4th gives me y to the 6th. Z fifth, z first, z third. You add all three of them together, giving me z to the 5, 6, 7, 8, 9. Z to the 9th. And there you go. That is the last of the video for today. Again, the objectives you should accomplish by the end of the day is learning how to use the product of powers property to simplify an algebraic expression, which we just got through doing.